Hi, welcome back to the Cuzzy Sound channel and part 9 in the series all about my little boxes. And this little box is a little jar. The bug jar. The inspiration from this came from the dead bug technique of building circuits, which is where you kind of solder things directly to the chips. And then I thought, well, if I'm going to do that, I'd like to kind of do something different with it. So as a kid, we used to kind of go into the garden with a jam jar and collect bugs and put them in the jar. So I thought, right, let's build some electronic bugs and put those in a little bug jar. So that's kind of where the inspiration came from to build this project. So what I needed to do next was decide which circuits would be the bugs in the jar. So I started prototyping things on the breadboard. My concept for the bug jar was to have a self-contained unit, so there would be an oscillator in there and there would be a speaker in there, and the speaker, here we go, was salvaged from an old telephone handset that a friend was throwing away, and I kind of ripped what I thought were the useful bits out of it, and that was one of the useful bits. So I wanted this self-contained unit, but with the oscillator, what I wanted, I didn't just want a single oscillator where I could just alter the pitch. I wanted to be able to do some kind of modulation on the oscillator. And so what I thought about using was something that gives me that kind of functionality, but with very, very few components. And that is this larger of the two chips here, which is a 4106 Mitt trigger hex inverter. The oscillator circuits for this are on the Hackaday Logic Noise series, and also the Module in a Week series used one of these. Now there's 6 inverters on there, so you can actually build up to 6 oscillators on the one chip, but I just needed 2, and I'll show you how I put those together. So really simple, very few components. Between the input and the output of an inverter you connect a potentiometer, and in this case I've got a 470k potentiometer. You then, between the input of the inverter and ground, you connect a capacitor, and on this side I've got a 22 nanofarad capacitor. And believe it or not, that's it. That, with a power supply, will give you an oscillator. Because of the values I've used, I get kind of a mid to high range. Now what you can do, and I got the instructions for this off the Hackaday article, is you can hard sync the output of one oscillator into another. So I built a second oscillator, and that's on this side of the chip. So it's another inverter, and across input and output I've got yet another 470k potentiometer, but this time between the input and ground I've got a 4.7 microfarad capacitor. Now using a bigger capacitor gives me a lower range of frequencies. So I've got a mid to high range and a low to mid range oscillators. And to hard sync them, you connect the output from one oscillator via a diode and a current limiting resistor into the input of your other oscillator. And the way around I've done this is I've taken the output from the low frequency oscillator. Now normally it would be something like a 4148 1N4148 signal diode, but I'm putting this in a glass jar, so I wanted some visual representation of the audio in the jar. So I decided to try and use a red LED in place of the 4148 signal diode, and then I've got the output from this oscillator going through the LED, current limiting resistor, and back to the input of the first oscillator. Now when I built this, I connected the speaker up to the output from the 4106 oscillators directly, and there wasn't enough power to drive the speaker. The speaker's actually a 1/2 watt 8 ohm speaker, which is actually more than I thought it was going to be in the telephone. Now fortunately there is a chip, the smaller one, the LM386, which is an amplifier which will give out 1/2 watt and drive an 8 ohm speaker. And again, it uses very few components to build an amplifier with a gain of 20. There's only a couple more to get it into much higher gain, but I just wanted to have a high enough gain just to drive the speaker. I haven't put a volume control on it. What I've done, I've put a fixed resistor between the output of the oscillator and the input of the amplifier to get a volume level that works for what I want to do. And that's it. That really is a very simple arrangement with very few components. But what does it sound like? Well, let's connect. I'll just put the negative supply of the battery in. Now hopefully you can hear there we've got a pulsed tone. Now the actual pitch is the first oscillator I showed with the 22 nanofarad capacitor. So if I start to now the other control is the low frequency oscillator, which is kind of carrying the signal of the first one. It's a bit like having an LFO on it, and so that's kind of, the pitch isn't changing, but the pulse rate is, the modulation. And hopefully what you've also noticed there is that I get a good visual representation of the audio. Turn this off. I get a good visual representation of the audio on the LED, in that it's flashing in response to the lower frequency oscillator, which is creating the pulse, but the brightness of the LED changes when I change the frequency of the higher pitched oscillator. So yeah, I've basically achieved what I wanted. A modulated oscillator, amplified so it'll drive its own speaker, with also an added bonus of a visual representation of the audio. So I took the circuit and I drew it out as a schematic, and that schematic looks like this. So you can see we've got the two oscillators on the left hand side there with the LED hard sinking in the middle, and then the output goes to the amplifier and off out to the speaker, and the whole thing is powered via the 9-volt battery. Now normally what I would do is show you a strip board layout for that circuit, but we're not doing a strip board. We're doing what's known as dead bugging. Basically you turn the chip on its back and solder the components to its legs, so kind of it looks like a pinned down dead bug. And so I had not done dead bugging before, and it took a while to actually think about the best way of putting it all together, but this is what I came up with. So that's kind of the whole of the circuit. We're going a little bit closer, we can see what the actual bugs themselves look like. And when I plugged it in and tested it, yes, it worked fine. So now it was just a case of getting my dead bug circuits into the glass jar. So let's go and have a look at how we did that. This is the jar with everything installed. So looking at the front here, you've got the speaker mounted on the front. In the middle of the speaker there is a hole drilled in the glass. It's not the first time I've drilled glasses. I've made bottle lamps before. One example is this. The problem with drilling in glass, I tried using ceramic drills, which seemed to cut quicker, but they also had a higher failure rate in terms of shattering the glass as you started to get to the point at which you broke through. So I resorted back to what I've used before, which basically it's the diamond engraving bits that you normally use for engraving on glass, but you get the right shape and take your time, you can carefully drill through. To be honest, drilling that one hole in the front there probably took me more than 2 hours on and off, trying to get the glass was actually thicker than I thought it was going to be, but I ended up with a single hole, which you'll hear will let the sound out. If it hadn't have done, I could have passed the wires through the hole and mounted the speaker on the outside. The speaker is attached to the inside of the glass with hot melt glue, which is how I've also attached the bug circuits. Blob of hot melt on the back and stick them on. And then to mount the battery, I've used 2 pieces of wood, similar to what I would use actually in a little boxer's build, but I've put a couple of basically the straps made out of the excess ends of cable ties. Then the only other thing was fitting the controls to the lid. So you can see there we've got the 2 potentiometers and the switch attached to the lid. So we've got the control for the pulse and the control for the pitch. If I turn it on, you should be able to hear. So and you can see there we've got the LED flashing away. And that is the bug jar. So if you've never had a go at dead bug circuits before, it's actually not quite as scary as you might think. You have to, let's turn it off, you have to think a little bit about how to arrange the components so that you don't short out other legs on the chips. But it's not that difficult. So yeah, go on. Have a go. Build your own